Hello friends, in this video let us discuss about busbar schemes in power system. There are different number of busbar schemes available in power system, and the selection of a particular busbar scheme depends upon the system voltage, and it also depends on the position of substation in power system. It also depends on flexibility required in system and also cost to be expensed. So these are the basic criteria to select a busbar scheme, and the main criteria to select a particular busbar scheme depends on the simplicity of system. So the busbar scheme design should be simple, and it depends on the easy maintenance of different equipments. It also depends on the minimizing the outage during maintenance. Minimizing the outage during maintenance. It also depends on optimizing the busbar scheme selection. Optimizing the busbar scheme selection so that it gives maximum return from the system. And the fifth criteria you can say is future provision of extension with growth of demand. So these are the five main criteria to be considered while selecting a particular busbar scheme. So now let us discuss the busbar schemes one by one. So let us first initially proceed with a single busbar scheme. Single busbar scheme. So the meaning of busbar is nothing but it is a system of electrical conductors in a generating or receiving station on which the power is concentrated for the distribution purpose. So that is the meaning of busbar. Now going with a single busbar scheme, in a single busbar scheme, the transformer and the feeder circuits are connected to a single busbar. So these are all going to your feeders. So here you are having an isolator. This is your isolator, this is the circuit breaker, and here it is your current transformer, and here you are having isolator, and this whole equipment is called as B. So the single busbar scheme is the cheapest and the simplest busbar scheme of different busbar schemes available, and the advantage of this single busbar scheme is it is simple in design, it is cost effective scheme, and it is convenient to operate. Now the disadvantage of this single busbar scheme is the maintenance of equipment of any bay cannot be possible without the interruption of the feeder and the transformer bay connected to the single busbar. So that is the only disadvantage, and it is basically used in indoor 11 kV switchboards. It is basically used in indoor 11 kV switchboards. Now, certain advantages or some advantages can be realized if the single busbar can be sectionalized with a circuit breaker. Now, let us sectionalize this single busbar with a circuit breaker. So, sectionalizing is nothing but dividing it into section. Thus, dividing the single busbar into sections. So here I am having the current transformer, this is your circuit breaker, and these are the two isolators. Now if there are more than one incoming sources and outgoing feeders, then the interruption of the power system can be reduced to certain extent. So if any of the sources is out of the system, still all loads can be fed by switching on this circuit breaker. By switching on this circuit breaker, all the loads can be fed if any of the sources is out of the system. And if any of the section, so this is for the even number of sections. So if any of the sources, suppose let us say for this busbar scheme, if there are more than one incoming sources and outgoing feeders and which are evenly distributed, So if I say there are two feeders in one section, two feeders in one section there, that means they are evenly distributed. Then and if any of the section is under maintenance, then the part load of the substation can be fed by energizing the other section of the bus bar scheme. So that is the advantage of the single bus bar scheme with bus sectionalizer. So this is sectionalizing, that means it is dividing the single bus bar into two groups, or you can say two sections. So the advantage is this. Now the disadvantage of this bus bar scheme with bus sectionalizer is again the maintenance of equipment of any bay cannot be possible without the interruption of the feeder and the transformers connected to that bay. This is your current transformer, and the isolators used here does not fulfill the purpose. So again the isolators have to be operated. The isolators have to be operated off circuit, and which is not possible without the interruption of the total bus bar. So the investment of bus coupler is required here. So now let us next proceed to the double bus bar scheme. So this is the diagram of your double bus bar scheme. So in a double bus bar scheme, two identical bus bars are used in such a way that the outgoing or incoming feeder can be taken from any of the two buses. So actually each feeder is connected to both of the buses in parallel through the individual isolators. So here both of the buses are energized, and the total number of feeders can be divided into two groups. The total number of feeders can be divided into two groups, and one group is fed from one bus and the other group is fed from the other bus. So, and at any moment of time, one feeder can be transferred from one bus to other bus through the isolators and the bus coupler used. So the bus coupler is used to couple the both buses. That is the function of this bus coupler. Bus coupler is coupling both of the buses. Now for the transfer operation of one feeder from one bus to other bus, the bus coupler should be kept closed, and first thing is you should keep the bus coupler closed and then close the isolator associated with the bus to where the feeder is transferred, and once you close the isolator to where the feeder is transferred, next open the isolator from where suppose if I want to transfer this feeder to this bus, let us say this is bus A, this is bus B. Now I want to transfer this feeder to bus A, then I will close this bus A isolator keeping the bus coupler closed, and then I will open the isolator of this bus B, and once the transfer operation is finished, then I will again open this bus coupler. So this is basically how the flexibility of system increases, and the disadvantage is the breaker maintenance is not permitted without the interruption of system. So this is your double bus bar scheme where two identical bus bars are used. Now let us proceed to double breaker bus bar scheme. Double breaker. So the only difference between the double bus bar and the double breaker scheme is here instead of using only the isolators, here we have used only the isolators to connect the feeder to the bus, but here this is your feeder. Here along with isolator we are also using, along with the isolator we are using the individual breakers with the respective buses. So here I am using isolator along with the bus, here along with the breakers, and here also I am using isolator along with the breakers. So that is the basic difference. So here the bus coupler is not required as the operation is performed by the breaker itself, but here the bus coupler is required as the operation is done by the isolators only. So again the feeders can be connected to both of the buses in parallel, and both of the buses can be energized, and the transfer operation can be performed by first First thing is closing the isolator to where the bus is, where the feeder is to be transferred. So if let us say this is bus A, this is bus B, and if I want to transfer the feeder to the bus A, then I will close the isolator associated with this bus, and then I will close the breaker. And after that, I will open the breaker of this bus bar B, and then I will open the isolator. So for transfer operation, close the isolator to where the bus is transferred, close the breaker to where the feeder is transferred, and open the breaker from where the feeder is transferred, and open the isolator from where the feeder is transferred. So this is your double breaker. Here we are using two breakers for a single feeder circuit. So for two breakers for a single feeder circuit, that means four breakers for two feeder circuits. Now let us move to the 1.5 breaker bus bar scheme. This is 1.5 breaker bus bar scheme. This is an improvement on the double breaker scheme in order to effect the saving of the number of breaker used. So here we are using 4 breaker, 2 feeder, that means 1 feeder, 2 breakers. So here one spare breaker is provided for every 2 circuits, and here we are using for 2 feeder circuits 3 breakers. 2 feeder circuits, 3 breakers, that means 1 feeder circuit I am using 1.5 breaker. So this is how the name came. For 1 feeder circuit you are using 1.5 breaker, for 1 feeder circuit here you are using 2 breakers, therefore double breaker, and this is 1.5 breaker. So the production is complicated since the central breaker has to be associated with the feeder whose breaker is out of maintenance. So the production is little complicated here, and the 2 feeder circuits are connected to 2 different buses, and here we can see the 3 isolators. So the power can be fed to the 3 feeders by closing all the 3 isolators. Now if any one of the breaker is out of maintenance, so let us say this breaker is out of maintenance, then the power can be fed to this feeder circuit via the breaker of the second feeder and the tie breaker. This is called as the tie breaker, which is basically coupling the 2 feeder circuits. So via the breaker of second feeder and the tie breaker, we are going to feed the power to this feeder circuit. Therefore the rating of the breaker should be kept in mind, as it has to feed the 2 feeder circuits when one breaker is under maintenance. Now let us move to the main and transfer bus system. Actually the advantage of this 1.5 breaker is that any faulty bus can be cleared instantly, and the interruption of feeder can be avoided by this 1.5 breaker bus scheme. So actually this is the power transformer. I have written current transformer. This is your power transformer, and this is your current transformer. So now let us proceed to the main and transfer bus system. So the basic differences from the double bus system is, so here let me say this is my transfer bus and this is my main bus. So here in the main and transfer bus system, every feeder is connected to the transfer bus system directly through an isolator. Through an individual isolator, every feeder is connected to the transfer bus, and that individual isolator can be called as bypass isolator. It can be called as bypass isolator. So this is the main conception behind the main and transfer bus. So suppose you can energize your transfer bus from this main bus via the bus coupler. So the bus coupler is basically used to couple the main and transfer bus system, and you can energize your transfer bus system from this bus coupler by using this main bus system, main bus. So by using the main bus and the bus coupler, we can energize the transfer bus, and thereby we can directly feed the feeder circuit through this bypass isolator. So now when the circuit breaker associated with the main circuit breaker are switched off, then the whole power gets instantly shifted to the bus coupler. Suppose let us say the circuit breaker associated, the main circuit breaker here is switched off or it is made out of the system, then the whole power gets concentrated or instantly shifted to the bus coupler, and the bus coupler in that way provides the purpose of protection. And in order to energize the transfer bus, first we have to close the isolators associated with the bus coupler breaker, and then close the bypass isolator which is connected to the transfer bus. And now once you close the bus coupler circuit breaker, you are going to energize your transfer bus and you can feed your feeder circuit. So this is basically the switching operation done in the main and transfer bus. So here the circuit breaker maintenance can be done without affecting the interruption of power supply. So without affecting the interruption of power supply, you are going to maintain any maintenance of this circuit breaker can be done. So that is the main advantage of this bus bar scheme, and it is basically used for 33 kV systems. Now next bus bar scheme you are having is double bus bar with bypass isolator. So with bypass isolator you are having double bus bar. So now for this connection only, what I do is I will use another isolator here. So the thing is, forget all this stuff from here to here. Let us consider only this part. So I will use another isolator here. So this makes my connection as double bus bar connection, and this bypass isolator makes it as the main and transfer bus connection. So any of the bus can be used as the main and transfer bus in the double bus bar system with bypass isolator, and the disadvantage of your double bus bar is the maintenance of the circuit breaker cannot be permitted without the interruption of system. But here with the bypass isolator we are going to use any of the bus as the main and transfer bus, and the maintenance of the circuit breaker can be done without interruption of the power. So without interruption of power, the maintenance of the circuit breaker can be done. So that is the main advantage of using this double bus bar with bypass isolator. Though there is a slight complication in the layout by using this bypass isolator, it can be economical. So it is economical to use for almost some 233 kV. Now let us move to the another bus bar scheme, that is the ring bus. So here every feeder is fed with two feeder circuits. Sorry, every feeder circuit is fed with two connections. So each feeder circuit is having two connections here, and the disadvantage of your ring bus system is, so in the earlier part of the video we have discussed future provision of the system is required with the growth of demand, but as it is a ring bus, it is a closed connection, the future provision of extension is not done, though that is one disadvantage. And if the ring bus, if any of the circuit breaker is under maintenance, then the ring bus becomes the open loop, comes under open loop, and if any of the breaker is tripped in this open loop, then all the feeders or all the feeders in between this tripped circuit breaker and the open loop gets interrupted. So if any of the breaker is under maintenance, then also you are going to feed your feeder circuits, as the feeder circuit is fed from two connections. So but once it becomes open loop, it the reliability of the system goes poor, and at that juncture or at that moment of open loop, if any of the breaker is tripped, then all of the feeder circuits are interrupted from the trip breaker to the open loop. So this is all about the busbar schemes used in power system. I hope you understood well. Please subscribe to the channel. Thank you.